In previous class we have seen the properties of irrational inequality, okay, and I have told you to use the name of properties of irrational inequality rather than the using word simple irrational properties of irrational inequality. You have to take a name Yamuna Babu 5 concept of irrational inequality, okay, and today we will explore it more, okay, the concept of the irrational inequality, the concept of irrational inequality, and what is the basic reason behind it, okay. Let's see, okay. It means that I have told you that under root of x square equals to mod of x. Under root of x square equals to mod of x, okay. Why I have told you under root of x square equals to mod of x? Because a square root is always positive. It means that a square root is always positive. Then under root of x square cannot be equals to x. That's okay. Cannot be equals to x. It means that first of all inside the square root, it should be greater than 0. It should be greater than equal to 0. First point, it should be greater than 0. If it is less than 0, what will happen? It will become a negative number here, and that will be a complex number. That is not defined in real number. But we have to use not the complex number. We have to use the properties of a square root in real number, okay. And we will study about the square root. We will study the square root of a complex number also, but we are studying here the properties of irrational inequality, okay. And I have given it name Yamuna Babu 5 concept of irrational inequality. Yamuna Babu 5 concept of irrational inequality, okay. Let's see it again, okay. I am writing it Yamuna Babu 5 concept of Yamuna Babu 5 concept of irrational inequalities. 5 concept of irrational inequalities, okay. And a square root is always positive. This is the main concept. A square root is always positive. This is the main concept of your irrational inequalities and irrational inequation, okay. Okay, let's see. What does the YB number 1 says? Yamuna Babu concept number 1 says that if under root of fx or 2nth 1 by 2nth power of fx equals to gx, it means that if a square root is positive, then gx must be positive. Then first point, gx must be positive, okay. Then you can apply the whole square both side. Okay, then you apply whole square both side here. Then you can ask a question here that why you are not inside the square root, why you are not saying that fx must be greater than equals to 0? Here it is obvious because gx you have made it positive. The value of a square root, you have made it already positive. Then there is no need to again say it fx greater than equals to 0, because the under root of fx or 1 by 2nth power of fx equals to gx. 1 by 2nth power of gx, 1 by 2nth power of fx equals to gx, and you have made it positive, but then there is no need to fx greater than equals to 0. If you wish, then you can apply. Then if you wish, then you can apply fx greater than equals to 0. But why should we increase more condition? It will be very simpler to us than to solve first and second condition. Then what will you do? You will take intersection. You will take intersection, because if gx greater than equals to 0 and fx equal to gx whole square, then from these two conditions simultaneously it will be correct. It will be correct that a square root will be the square root will be is equals to gx, is equals to gx. Then we have to apply these two conditions only. This says YB concept number 1. That's okay. Okay, let's see the second YB concept number 2. YB concept number 2. Okay, you have to remember only the square root is always positive. That is the keyword. That is the keyword of your irrational inequality. That is your keyword of irrational inequality. Okay, let's see. The YB concept number 2 says 2nth 1 by 2nth power of fx is less than gx. Okay, 1 by 2nth power of fx is less than gx. That's okay. First of all, as we know that under root of fx is positive, and if any number is positive and it is again less than any expression, and again it is less than any expression, then it should also be at least must be positive. It means that is the first condition. Gx must be greater than 0, not even equals to 0. It must be greater than 0. That is the concept. Okay, and the second point is fx equals to, then you can apply whole square. Because a square root is positive and gx you have applied whole square both sides, then 1 by 2nth power or 2nth power, you have applied 2nth power both sides. 2nth power both sides, it means that you have fx is less than gx to the power 2n. That's okay. And the third point is you are saying that fx less than gx to the power 2n, there is no information about under root of fx. There is no information about under root of fx from this inequality. So, and this expression you are saying that the under root of fx is less than gx. It means under root must be defined. It may be inside the square root, it may be negative. So you have to here apply fx must be greater than equals to 0, and here I have not applied. Why? Because there is no need to apply fx greater than equals to 0. There is no need to apply fx greater than equals to 0. Why? Because you are saying that a square root is equals to there exists any expression, and you have made it already positive. Then there is no need to solve the third condition, fx does not equals to 0. But if you wish, you can solve it here also. Okay, there is no any restriction about it. Okay, let's see. Then but the concept is here that here gx is greater than 0 and under root or 1 by 2nth power of fx is less than gs. Under 1 by 2nth power of fx is less than gx, then fx and you are applying 2nth power both side. Then fx less than gx to the power 2n. Okay, and the third point is fx greater than equals to 0. Why it is necessary here? It is necessary here because the square root of fx, a square root of fx is less than gx, and then this square root must be at least defined. This square root must be defined. Okay. Then in this condition you have to apply, only one intersection, condition 1 intersection, condition 2 intersection, condition 3. There is no any doubt here now? Okay, let's see the third condition. Third condition. What is the concept number? What is the YB concept number 3? Yamuna Babu concept number 3 says, this is 3, okay, and here less than gx, okay. Then 2nth, 1 by 2nth power of fx is greater than gx. 1 by 2nth power of fx is greater than gx. It means that, first, think basically here that what is the keyword? Our keyword is square root is always positive. That is the keyword only, okay. And by applying here, you have to apply square root is always positive, okay. It means that if a square root is always positive, and consider here case first, that gx is less than 0. Gx is any number or expression which is less than 0. Gx is any number or less than 0. Gx is any number or expression which is less than 0. Gx is any number or expression which is less than 0. Then it means that a square root is always positive. Then we have to define only the square root. Because it is always true that a square root of any positive number, must be greater than negative expression. There not should be any doubt, okay. There should not be any doubt, because this is, if you are saying, if you are taking case first that gx is less than 0, when it is negative, then it and you have defined, if you have to define only that fx must be greater than equals to 0, then it will be always positive, and it is always greater than a negative expression, because you have taken gx less than 0. That's okay. Then we have to define only fx greater than equals to 0. Okay, and the second case, when you see the second case, what second case says that when you take gx is positive, it means here this is a positive expression, then it must be positive, because a square root is a positive expression. It means that when you are taking this as a non-negative, then you have to apply fx 2nth power both sides, and as we know that a square root is always positive, then there is no need to apply the fx greater than equals to 0 here also, okay. In that I want to say that if you take gx greater than 0, gx greater than equals to 0, it means gx is non-negative. It means that fx is greater than gx whole square. And if you define that fx is greater than equals to 0, if you define here also fx greater than equals to 0, but as we know that because any square root is greater than any positive real number or positive real expression, if and only if it means that a square root also must be positive, a square root also must be positive. That's why there is no need of condition of condition 3. You can use it only first and second. Okay, then in between two you will take intersection. What we will take? You will take intersection. This is the case first. You will take one intersection 2 here, and there you will take one intersection 2 here, and the answer will be case 1 union case 1 union, or case A, name it case A or case B, then case A union case B. That's okay. Is there any doubt? I think there should not be any doubt, because I have explained I have explained all the expression. Okay, let's see the YB concept number 4. YB concept number 4 says, YB concept number 4, and what I have taught you these three concepts, of inequalities, irrational inequalities, and then these 4 and 5, then YB concept number 4 and YB concept number 5 is as similar as you have read here, second and third concept. Okay, then see it carefully. What I am saying that first condition is, let's see here 2nth power 1 by 2nth power of fx is less than g. Okay, no, less than 1 upon gx. Okay, then you have to take an example. Then you have to take a simple example. I am taking a simple example that root x by x is less than 1. Okay, root x by x is less than 1. It means that when you are saying that x is less than 0, it means here you are taking a negative expression. It means that when you multiply this x into this into 1, then it means that root x will be greater than x, and x is less than 0, and for x is less than 0, and you are saying that x must be greater than equals to 0. X greater than equals to 0. And here you have to take condition x less than 0, and you are finding the solution x greater than equals to 0, because square root is defined only when x greater than equals to 0. Then it is not possible. That root x by x less than 1. This is a very typical concept, very typical concept, that you can note it here, that by taking example it has come out obviously that root x by x less than, can't be less than 1. Okay, why? Let's see again. Because x less than 0. You have taken x less than 0, and when you are taking x less than 0, it means this is a negative expression, and you are multiplying in this inequality, and x is less than 0. Then inequality will change. It means that root x is greater than x. Root x is greater than x. Then you have to define a square root also, that here x must be greater than equals to 0, and this is the first condition, and this is the second condition. You have to take intersection only, one intersection 2. You have to take intersection between these two, one intersection 2. When you will take intersection, the intersection will be 5. Because you are from here you are taking 0 less than, and you are finding your solution that x is greater than equals to 0. There is no intersection between these two intervals. No, there is no intersection between these two intervals. Okay, that's why I am saying that root x by x cannot be less than cannot be less than 1. Okay, this is a very, very typical concept. Okay, note it here. Okay, and this I am exploring this concept. Let's see here. Okay, similarly you can say 1 by 2nth power of fx is less than gx. 1 by 2nth power of fx is less than gx. No, by gx less than 1. That first condition, as when you take gx is negative, when you take gx is negative, it means that when you multiply this expression, when you take gx is negative, you multiply this expression into 1, then 1 by 2nth power of fx is greater than gx. 1 by 2nth power of fx is greater than gx, and you have taken gx less than 0, then you have to define only the square root. It means that the second condition will be fx greater than equals to 0, and you have to take 1 intersection 2. Oh, that is the similar case. What I have read in YB concept number 2 and YB concept number 3. And this is the case first. Okay, and case second. Wait a second. Case second is. What case second is? Wait a second. My phone is ringing. Okay. Case second is. Wait. Case second is. Okay. Case second is that when you take gx is greater than 0, when you take gx greater than 0, it means that but as you know the denominator cannot be equals to 0. It means that when you are taking gx greater than 0, the inequality will look like as it is, as this expression. And we have read already about this inequality. That what is the condition of this inequality? That gx is greater than 0, then you have to apply both sides fx less than gx whole square, and the third condition is fx greater than equals to 0. Okay, and we have read it already. This is the concept. This is the YB concept number 2. Okay, and the last YB concept number 5. YB concept number 5, what says? It says that 1 by 2nth power of fx upon gx is greater than 1. Then it is simply that, then you should think that this is an expression, and you are saying that this expression is greater than 1. It means that if it is greater than 1, it must be positive. It means gx must be greater than 0. Okay, and if gx is greater than 0, then you have to apply only fx. Then you can multiply here. Fx is greater than gx to the power 2n. Okay, to the power 2n here. Okay, that's okay. These are the explanation that I have given you about the properties of irrational inequality, and I will name it as a Yamuna Babu 5 concept of irrational inequality. Okay, I think there will be no doubt as I have explained it very briefly. Okay, let's see the example. Okay, First example, what the first example says? First example says under root of 1 plus x into x square plus 24. Let me see the page. Okay, let me see the page. What is the question? Okay, 1 plus x under root x square plus 24 equals to x plus 1. I will apply the YB concept number 1. Yamna Babu, concept number 1 of irrational inequality. Yeah, I am naming it as Yamna Babu because it is the unique name. You will remember always. Okay, you will remember always. Okay, then what we have to do? First, if a square root is a square root of any function or any expression is equals to a square root of any expression is equals to x plus 1, it means that first point is it must be greater than 0. X plus 1 must be greater than 0. It means x greater than minus 1. Okay, and the second one, then you can take a square both sides. Okay, then 1 plus x into under root of x square plus 24 equals to x plus 1 whole square. It means that then you can break it in for full expression, x square plus 2x plus 1. Okay, then cancel 1 and 1. Okay, and x into under root of x square plus 24, and then you take x common here and you have to square again. That will be x square into x square plus 24 into x square into x plus 2 to the whole square. Have you any problem? Okay, no. Then x square into x square plus 24. Then you have to not cancel. You have to not cancel here. You have to not. Okay. Oh. Then you have to not cancel here x square and x square. You have to take it as a minus here. Then x square into x square plus 24 a minus x square into x plus 2 to the whole square equals to 0. Then you will take x square as a common, x square plus 24 minus x plus 2 to the whole square. Then x square plus minus 4x and equals to 0, and x, you can cancel it here, x square and x square, and 24 minus 4 20, and 20 minus 4x, x square into 20 minus 4x, x square into 20 minus 4x. You have got x square into 20 minus 4x. It means that x square equals to 0 and 20 minus 4x equals to 0. Then x equals to 5 and x equals to 0, and this is your answer. Okay, it means that we have done nothing. We have applied YB number 1. YB number 1 says if a square root of any expression, function I am not naming as a function because I have not taught you as a function. You can say it here as a function also. There is no there should not be any confusion about the function and expression. Expression is simply this. Okay, and you can say it collectively as an expression also. Okay. Then this is equals to x plus 1, this is equals to x plus 1, you have to x plus 1 greater than 0. Mainly you have to think about the square root of any expression. Okay, you have to mainly think about the square root of any expression, and the only keyword of the irrational inequality, only keyword of the irrational inequality is that a square root is always positive, and inside the square root it also must be greater than equals to 0. Okay, let's see the second question. Second question says that under root of 3x minus x square is less than 4 minus x. Am I right? Okay, I am right. 4 minus x. Then what you have to do? Here a square root of this expression is less than 4 minus x, then first it means that it must be greater than 0, because the square root is always positive. How it is possible that a square root of any expression is less than a negative number? It means that it must be a positive. 4 minus x must be a positive. That's okay. And then you can apply whole square both side. Second, then from here you will find x less than 4, and you have to square both side. 3x minus x square is less than 4 minus x whole square. Okay, then you have to break it. 3x minus x square less than 4, 16 plus x square minus 4 to the 8x. Am I right? Okay. It means that this is 16 plus 2x square, 16 plus 2x square, and this is minus 11x. 11x is greater than 0. It means that 2x square minus 11x plus 16 is greater than 0. Then you have to check it first discriminant. What the discriminant here? Discriminant will be b square 11 whole square minus 4a. A, what is a? 2. What is c? 16. It means that here 121 and here is 128. 16 4 ja 64, 2 ja 128. It means that it is less than 0. And when the quadratic is less than 0, and the coefficient of x square when the quadratic is greater than 0, no, less than 0, no, when quadratic is greater than 0, okay, and its discriminant is less than 0, and its coefficient of x square is positive, then you will say the quadratic will always positive for all value of x. For x belongs to real, it must be greater than 0. I have taught you already. Okay, it means that from here we have find x belongs to real number. It means that, and where is the second condition? This is the first condition and this is the second condition. Okay, and you have to define the square root also, no? You have to define a square root also, because if it is a negative, there is no meaning of that a square root of any expression is less than 4 minus x. That's okay now? Okay, it means the third condition will be 3x minus x square is greater than equals to 0. 3x minus x square is greater than equals to 0. And I have taught you that you have to first make the coefficient of x square positive here. X square minus 3x less than 0, and this is x minus 0 into x minus 3 less than 0. And I have taught you the tricky concept that when you find this expression less than equals to 0, you have to say chotki to badki. Chotki means a smaller one, badki means bigger one. Okay, chotki means 0 and bigger one is 3. Okay, that's okay. And x belongs to 0 to 3. Okay, and you have to take intersection between these three conditions. What will be the intersection? You should think here directly that it is x less than equals to, no, this is x less than 4. This is x less than 4. This is x belongs to real number, and this is belonging 0 to 3. It means here it is saying less than 4, here real number, and here 0 to 3. The intersection will be 0 to 3, and the answer will be 0 to 3. And you can plot it on a number line also. Okay. If you have any confusion, then plot it on a number line. Where is the question number 3? Question number 3. We are watching the properties of we are watching the question of irrational inequality, and this and you are applying the square root must be positive, and you are applying what? That here you have defined 3x minus x square greater than equals to 0, and because this expression is less than 4 minus x, and if it is great if it is greater than 4 minus x, then there is no need to apply here that 3x minus x square greater than equals to 0. You must remember it. Okay, then let's see the next example. This what is the next example? Okay, next example is very interesting. Minus of x square minus 3x minus 2 minus of x square minus 3x minus 2 is greater than 2x plus 3, is greater than 2x plus 3. Okay, is greater than 2x plus 3. Okay, is greater than 2x plus 3. Okay, first of all, then see the inequality here, and what would you want to tell here? That you will say that sir, 2x plus 3 when 2x plus 3 less than 0, when 2x plus 3 less than 0, the square root of, as we know that a square root of any expression is always positive. Okay, not any expression, a square root of any positive expression is always positive, and when it is less than 0, it means it will be always true that a square root of this expression is greater than 2x plus 3. We have to define only the square root function. We have to define the square root function. How we will define it? We will define by making it greater than equals to 0. It means that you have to apply minus sign here, x square plus 3x plus 2 less than equals to 0. Okay, and this is the case first. This is the case A, that 2x plus 3 less than 0, and the case second will be what? 2x plus 3 greater than 0. Let first solve here. Then x square plus 3x plus 2 is less than equals to 0. It means that what will you write here? X plus 1 into x plus 2, because this have factor 1 and 2, and you can think that 1 plus 2 equals to 3, and you can apply here also that x plus 1 into x plus 2 less than equals to 0, and as I have already told, the value of x will be smaller one to bigger one. Okay, a smaller one is minus 2. You have to zero it in your mind. Okay, that is minus 2 to minus 1. That's okay. And 2x plus 3 is greater than 0. 2x plus 3 is greater than 0. When 2x plus 3 is greater than 0, you have to think here. Then is a square, this square root is greater than 2x plus 3, then square both side. Okay, and here x greater than minus 3 by 2. Okay, here we have got x less than minus 3 by 2, x less than minus 3 by 2, and from here and here you have to take intersection between these two conditions. It means that x belongs to minus 2 to minus 3 by 2. That's okay. Okay, this is the case first. This is the answer of case first, and we are taking case second. 2x plus 3 is greater than 0. It means that x greater than minus 3 by 2, and then you have to apply whole square both side. Minus of x square minus 3x2 greater than 2x plus 3 whole square. It means that minus of x square minus 3x minus 2 greater than, what will happen here? 4x square plus 9 plus 12x. That's okay. Okay, and when you add here, that will be 5x square plus 15x plus 9 to 11 is greater than 0. Okay, and you should check here discriminant. What will be the discriminant? 15 whole square minus 4 into 5 into 11, and 15 whole square, that is equals to 2 to 5, and 5 4s are 20 into 11, that is 20 to 25 minus 2 to 0, that is equals to 5. It means discriminant is greater than 0. Then we have to solve the inequality. Okay, then it means that it means that x equals to minus of 15 plus minus under root of 5, because discriminant is 5, under root d by 2a, d by under root d by 2a, 2 into 5. It means that x equals to minus 15 of plus minus under root 5 by 10. Okay, and here greater than sign, here the sign is greater than, then you have to write it directly. X will be minus infinity to a smaller one. Which is a smaller one? Minus 15 minus 5 by root 5 by 10, and union minus of 15 plus root 5 by 10 to infinity. That's okay. Minus 15 plus root 5 by 10 to infinity, and the case is x greater than minus 3 by 2, x greater than minus 3 by 2, and here is which will be greater, minus 3 by 2, or we have to take intersection between these two conditions, that and this is smaller than minus 3 by 2, because minus 15 and it is around 2, then minus 15 or minus 15 and minus 2, minus 17. It means that minus 1.7, which is less than minus 3 by 2, It means that when we will take intersection, what will happen? Minus 1 minus here let's see here that this is minus 1.7 and it is greater than minus 3 by 2, then it is above from it, or after this real number. Okay, it means x greater than minus 3 by 2, and this is minus 15 plus root 5 by 2, and minus 15 plus root 5 by 2, that will be greater than minus 3 by 2. Okay, because its negative is less than, its negative is greater than minus 3 by 2. It means that when you will take intersection, the answer will be minus 15 plus root 5 by 10, minus 15 plus root 10 to infinity. That's okay. Okay, then here there is little bit typical calculation here. Okay, and when you are saying that minus 2 to the minus 3 by 2, okay, check it yourself. Okay, here only you have to calculate the value which one is greater, and you have to solve the inequality, and you will take an intersection and union. Okay, there should not be any doubt. Okay, then what will you remember in this class of properties of irrational inequalities? That you will first name it as tutubabu 5 concept of irrational inequality, and second one, all concept will arise from the properties of a square root, and as we know that square root is always a positive. That's correct. Okay, we will meet next day. Thank you.